Excavator rippers, otherwise known as frost rippers, are an essential tool in the excavator owner's attachment loadout. Built for maximum penetration, ripper attachments tear through tough soil and frozen ground with rugged force. Gussets provide heavy-duty ripping power, and a heavy-duty shank reinforces the attachment structure for maximum uptime protection in the field. The single-point tooth design delivers optimum penetration, ripping through frozen ground and through root systems with ease. To begin, extreme-duty 1 1/4 inch steel is cut out in the outline of a ripper on a plasma table, like a cookie cutter. Plasma cutters use compressed air or other gases, such as nitrogen. As the plasma arc contacts the metal, it melts under the high temperatures, approaching 40,000 degrees Fahrenheit. At the same time, the high-speed gases blow away the molten metal, allowing the tip to move across a pre-programmed path, cutting the steel into the desired shape. The rough edges created from the cutting process are then smoothed using a right-angle grinder to prepare them for welding. The worker then uses a high-powered electromagnet to pick up and move the ripper-shaped steel onto a pallet. The pallet is then moved across the factory via forklift to the welding cells. While the main body of the rippers are being cut, the top components are being machined in a CNC mill. The machinist drills and taps holes in the plate that will allow it to be bolted to the appropriate modular top that will attach to the excavator. They engrave the number for the weight class of the excavator it'll be mounted on for easy identification. The cut steel is then installed into a jig that locks them into place on a rotating table, like a rotisserie. The table rotates around a center axis, allowing the welding robots to reach 360 degrees around the jig to weld at any angle. Programmers have already mapped out the precise paths the robots need to travel in order to make welds that will ensure these heavy-duty rippers can hold up under extreme conditions. The worker presses go, and the robots get to work. These Lincoln welders and Fanuc robots are purpose-built for high-volume, non-stop work. Wire feed welders, also known as metal inert gas or MIG welders, operate via an arc welding process that uses a continuous solid wire electrode, heated and fed into the weld pool from a welding gun. This is manufacturing automated. The automation saves time and labor, freeing up workers to dedicate their time to tasks that aren't cost-effective to automate. The automation also ensures consistency and speed of manufacturing in these high-volume items to meet the needs of the industry professionals putting them to work in the field. Landscapers, hardscapers, demolition experts, utility workers, and forestry professionals all use and abuse these attachments, and the demand is ever growing as more land is developed and more properties are improved. Once the rippers are fully welded, they move to the final stages of manufacturing: sandblast and powder coat. Before they can be powder coated, they need to be sandblasted. The worker uses compressed air mixed with sand or other abrasives to strip the ripper down to bare steel. Powder coating is a dry finishing process created by an electric charge that causes a dry powder to fuse to the surface of the metal. The worker uses a special gun to apply the powder in a designated booth that filters the air and provides ample light so no surfaces are missed. The ripper is then baked in a curing oven to achieve a smooth coating. This creates a thick, flexible finish that is tougher than conventional paint and will prevent rust in all the non-wear areas. Once the baked rippers have had time to cool and cure, they're palletized and ready to ship out to hard-working customers. Made here, made better. CMP.